using plants and soil to suck up and evapotranspire the water, or even store it temporarily, and go back to that natural hydrology. You know, try to use nature to our advantage and get rid of some of this water before it gets into the storm sewer and causes a problem. You know, so I think of it as, you know, it's multiple. It's like a distributed system of vegetation that sucks up the water, keeps it out of the sewer system, and reduces flooding, reduces flows going out to our waters. And so it's a pretty, I think, simple concept. The idea is just let plants do what plants do best. I think it's challenging, obviously, to implement for a multitude of reasons. For one, I'm an engineer. Engineers really like pipes and tanks because they feel like they understand them better than they understand plants. You know, plants vary seasonally. You know, like a pipe always does what a pipe does, no matter what's happening. But like plants, like, oh, I don't know. It makes engineers nervous. I'm not gonna lie. So that is one of the problems with implementing these, is just understanding how they perform, so that kind of the technical people that are usually dealing with sewer systems can feel comfortable implementing these types of practices. So, you know, what are we talking about? It could be something as simple as a rain barrel that you put in your backyard and you disconnect your downspout to, and now you've stored some water during a rain event. You use it when it's not raining. You know, that's green infrastructure. Green roofs, a little higher technology, but, you know, in cities that have lots of flat roofs, this could be a great option. You know, you can grow food on them. You can do lots of different things with them, depending on what your goals are. Rain gardens, is like a depressed garden area that you, again, let the downspouts of your roof run off into. In this case, it looks like they've also cut the curb so that the water from the street will enter into this garden. And so another kind of beautiful way to deal with stormwater before it gets into the sewer system. And I included this list actually as a partial list from the EPA. And at the end, they have urban tree canopy and land conservation. And I think of those as the original green infrastructure, you know, planting trees, not developing land. I mean, that's the original green infrastructure. That's the way to, you know, keep surfaces unpaved. Then the water that hits them will infiltrate. And trees, obviously, they need a lot of water. But the way that we typically plant trees, you know, doesn't allow, it's only the water that falls on them that really gets in there. And so what I think green infrastructure is trying to do is to funnel more water into these vegetated spaces so that they can handle, they obviously can handle more water. We have a problem of having to go out and water street trees, but yet, you know, you have all this water just flowing right by in the gutter, you know, and it seems like, oh, why don't we just design them so that water always goes into the tree? And I think that's what green infrastructure is trying to do, is to connect these vegetated systems with the stormwater runoff that's coming off all of our paved surfaces, so that, you know, we can suck up as much as we can and hopefully reduce flooding. I've kind of gone over some of the benefits, but kind of a big difference between hard infrastructure and green infrastructure, and people talk about all the time, is the co-benefits that you get from these vegetated systems. So the list on the right is talking about, you know, when you have a vegetated system, you're improving air quality, you're combating urban heat island effect, you're creating habitat for wildlife, you're beautifying your neighborhood, and depending on how you build them, you can potentially be creating green jobs. So I think that that's a lot of pressure to put on a small garden, but I think the idea of co-benefits is really important. It's the major difference between, you know, that tank that I showed that's underground, you know, that's all, let's say, taxpayer money, really literally being buried in the ground. You never see it again. No one thinks about it. No one thinks about their storm sewers until it's flooding, but like, you know, no one's thinking about what's underground. But as you build green infrastructure, now you have something that people see. It makes them think about, oh, what is happening to my water? Why did they put this here? You know, it gives us something to talk about. And it also does and can have these co-benefits. My word of caution is that I do think that process is important. So how you build these is also just as important as getting them built. And I'll kind of explain, I will embellish on that a little bit more in my presentation, but I don't think that these co-benefits just, not all of them just naturally will be a part of your project. You kind of have to be intentional about it. And so let's talk about In Haven. So what I'm going to be focusing on mostly is the Bioswale. So it's basically a curbside garden, an engineered garden, very similar to that rain garden picture that was shown earlier. But this is the kind of primary form. You know, I work for a city, and green infrastructure can be built on private land or on public land, but we, you know, have control over the public right of way, and so that's what I've been focused on building. And so the Bioswale, I stole this from New York City. You'll see that we borrow from our neighbors quite often, and that's okay. You know, I mean, no need to recreate the wheel. So the idea is that, you know, the water's coming down the street. There's an inlet, there's a cut in the curb, you know, so instead of it just continuing to go down and go into the catch basin and into the sewer, you cut the curb, and now the water enters the garden. It flows through the vegetation. These gardens are 5 feet deep. We dig them out 5 feet, and we put some stone on the bottom. And the stone is there to create pore space so that water can get stored in there during a storm event and then infiltrate into the ground. And we use like a highly sandy soil for these plants. So it also has a high infiltration rate, sucks up more water. So it's, you know, the water travels through here, and then it is not shown very, oh no, here it is. Okay, so in this diagram, it's over here, we put it at the end. But this is like a stone gabion. And basically all that is it's a cage filled with, cage filled with rocks. And what it does is it allows the water to short circuit. So once the soil's filled up and the plants are, you know, flooded, these are designed to flood a little bit, the water goes into this gabion, and the rocks just short circuit. It's like an elevator down into the storage layer, and it shoots all that excess water into the stone layer and then into the deep infiltration that you get in your soils. And that's ultimately where we want the water to go, either be evaporated by the plants or infiltrated by the bioswale into the soil, and eventually into groundwater. And through this process, it's filtered. There is microbial action that cleans out pollutants. And so you have a cleaner product going into your groundwater system. And we don't actually build an overflow, but some of them have overflows. And so any excess water that can't get into the soil or into this rock layer goes back to the catch basin the way it was going to go anyway, but it's a lot less than would have been. So how did we start implementing green infrastructure? Is probably what you're wondering, as you are all leaders, and I think trying to get your towns, maybe thinking about getting your towns to implement green infrastructure. So actually our first, and this is not a great picture because it's winter, so I apologize, but our first bioswale was born out of necessity. They were doing a sewer project, and they wanted to put a catch basin in the road, but there were too many utilities and they couldn't fit the catch basin. And so they had this low point in the road, and all the water was going to pond there, and they didn't know what to do. They were already, you know, constructing, they were in this project was already happening. And the city engineer, my boss, who wasn't city engineer at the time, had been watching what had been happening in the cities around us, including New York City, and said, hey, this was 2013. New York City adopted a green infrastructure program in 2010. They said, hey, they're installing these bioswales. Why don't we try one of those? And out of desperation, they were like, okay, fine. And so the engineering department kind of, most cities are sharing their designs online. Picked up the design online, and we work with a local nonprofit to do tree planting. And we asked them, hey, would you be interested in trying to build this bioswale? And they said yes. And so that is kind of how the first bioswale was built. It was, with a design that wasn't ours, out of desperation. And what happened is it worked. The water that would have pooled on the street wasn't pooling on the street. It was going into this bioswale and getting sucked up. And so, everyone kind of noticed and said, that's interesting. Maybe we should try this out again. And so the one thing with New Haven is we are located on very sandy soils, which is good for infiltration. Imagine going to a beach and pouring water, it just goes right in. And so we are very fortunate and are in a good spot for having the ability to infiltrate a lot of water. If you're located on bedrock or clay, it could be more challenging. There's ways around to design around it, but it is a little more challenging. So the second bioswale was this much larger iteration of the first one. But what they were finding was that they were kind of difficult to construct and very costly. And so for our city, we don't have a huge, we don't have a lot of excess amount of money. We're like a typical city. And so we needed to find a way to kind of make them cheaper and more buildable. And so I think the first stage is just getting over the hump of trying something new. And for us, that was born out of necessity. And then kind of being like, you can paint it to your town managers or whatever as it's really low risk, right? If this doesn't work, what happens? The water's going to go down to the catch basin the way it always went, right? So in some ways, it's kind of a low risk intervention. It's relatively low cost, compared to digging up a road and putting a new pipe in or something, So to get one in, you kind of just have to overcome the fear, whatever fear ends up being, how you're going to maintain it, what is it, what do plants do, how is this going to work? You can get over that fear and just install one, then you can tweak. A lot of what we've done is adaptive design, and that's kind of what I'll talk about next. So the nonprofit I mentioned is a really important part of our program. We kind of say that nonprofits are good at things that we're not. They're good at working with community. They're good at building relationships. They're good at communicating. So they're good at things that we are not. And so partnering with them is really important. And, we really believe that green infrastructure, in order to get the most benefits out of it, really needs to be built differently than we build kind of other infrastructure. So the nonprofit works with another nonprofit, and I'll get into that, but there's like a workforce development aspect to what we're doing. And so they applied for a grant. So we don't have a stormwater fee. We don't have, our utility for sanitary sewage is privatized. So we don't have our own funding source necessarily for green infrastructure. So we really rely on grants. And we were able to find a small grant that would help us, I call this stage 2 proof of concept, So we wanted to, we worked with Yale University to measure performance, right? We wanted to know, we kind of anecdotally know that they're capturing water, but how much water are they capturing? So we wanted to answer that question. We also wanted to experiment with the design. We're working with low-skill laborers in this case, and we wanted to take out all the complexity that we were finding with the New York City design and make it easy to install. And so this grant covered 7 bioswales within a block. And they tweaked the design. They tried different walls because they were having to pour this concrete header and they didn't like that, and different ways to install the fence, and different inlets and different materials. And we just like played around with the design to see what was easy to construct and then what also worked. And so, and this was very important to us because the tree planting nonprofit works with another nonprofit that works called Emerge, and they work with previously incarcerated persons as like a reentry program back into their world after prison. And so again, things that we're good at, that they're good at, that we're not. And this program, the members work 3 days a week, and then they have two days of social programs to help them, gently enter back into society. And so it was really important for us to work with them. And so we're like, we have to find a way to build these that uses labor. We had a lot of labor. We didn't want to have to use machinery or limit the amount of machinery. And we didn't want to have to use complex materials or, skilled, concrete forming and such. So, we hand dig these 5 feet. We backfill these all by hand. We place all the materials by hand, and we've worked with the design. And so I think, to make it so that they can do most of the work by hand. And that, this is what I mean by the co-benefits don't come naturally. You can make a bioswale really complicated and hard to build where you have to just hire a contractor to do it. And that's fine. I mean, you'll still get the flooding benefits and you'll still get the stormwater capture, and that's okay. But if you want some of these other co-benefits that people attach to green infrastructure, there are ways to be more intentional about that. And then outreach. I can't stress how important it is to engage everyone, but particularly the ones that are going to be located near these projects. I think I worked in New York City for a while before coming to New Haven, and my experience there was one where people were kind of shocked. All of a sudden someone was coming in front of their home, digging up their sidewalk. Even if they liked the end result, they just didn't like that they weren't told. They didn't know it was happening. It takes us 2 days to build a bioswale. The first day is the most disruptive because a lot of times we're digging, we're breaking concrete and removing a piece of the sidewalk, cutting curbs. It's loud, it's not great, but it's very short term, So we knock on doors. Again, nonprofits better at this than we are, but knock on doors of adjacent homeowners and let them know what's happening. We don't have to ask permission, but and we actually have a high acceptance rate of these in our city, and I think it's because of the way we've gone about doing it. Because we show them what the outcome's going to be, and generally people are pretty accepting of it. I think that we all like to be included and we like to know what's happening in our neighborhoods, and I think there's a real feeling of powerlessness if you just kind of come in and do something without engaging. And so I do think that element of our program is really, really important. And so this was like a door hanger, if someone's not home, that we can leave on the door. In some projects, this is actually a rain garden, we have volunteers do the planting, any way you can engage people to be a part of these projects, because we know that builds stewardship in the long run. If people feel they were a part of it, they're more likely to look after these and make sure that they're functioning. We have a maintenance program, but it's hard, we can't get out there every week. So, you know, if there's garbage floating into these, or, people have become stewards and will clean up if they've been a part of it and they feel some sort of ownership over it. And so I would say stage 3 is kind of 2 parts. We've tweaked the design so much that it's become kind of standardized so that we could implement many of them rather than having to think about the design of each one. And then, you know, now that we've researched them, we know that they work, we're more comfortable with them, widespread adoption was easier. Again, I'm kind of showing here different reasons why we've installed them. So starting with the localized drainage issue, this is a different site, but you could see the water just had nowhere to go. For us to put a catch basin and put new pipe all the way down the street would have been very expensive. We ended up putting a bioswale right here, and the problem went away. So kind of a low cost solution to what could be a really costly drainage improvement. You know, we researched, we've gotten grants to do research. You know, I was talking about the combined sewer and the problem of the mixing of the sewage and stormwater. So we've actually, our sewer authority has also gotten grants now to install 70 bioswales in their combined sewer areas, trying to, you know, it won't solve the whole problem, but it's part of the solution now. And so they've gotten grants to do that work. And then we had a larger grant to build 200 bioswales. So after Hurricane Sandy, you know, the whole Northeast was kind of devastated by it. And that opened up some funds for disaster recovery. And the city put in a grant to build green infrastructure as part of a, you know, it's easy to implement in some ways, right? It's faster than designing and coming up with like these large infrastructure solutions. And so we put in a $4 million grant. 2.5 of it was to build green infrastructure, and 1.5 was to design the hard infrastructure that we'd need to deal with the flooding afterwards. So, you know, it doesn't have to be all green or all gray. You know, I think the green complements the gray and really will, we're finding, will decrease the amount of hard infrastructure we have to build in the long run. And now it's kind of infiltrating the engineering department, no pun intended. This was a traffic calming project. So we were bumping out the curb, and this is actually a raised intersection, so people would have to, you know, slow down to go up and over this intersection, and we put in these rapid response pedestrian crossing signs. And but when you bump out the curb, sometimes you cause a drainage problem. And to us, we were like, oh, well, we'll just put a bioswale there, and that, you know, the water will get sucked up into the bioswale. And so, you know, kind of a close up of what that looks like. You know, the water going along the curb, we put a cut along the curb. It infiltrates into the bioswale first, and then overflows into the sewer system when it's filled up. And so this is kind of it in action. So it's kind of just green infrastructure has just become part of the way we do our work. You know, we look to use green infrastructure first if we can, and if we can't, then we look to other solutions. You know, we all live in a funded, cash-strapped world, and we need our money to do more than just one thing at a time. You know, there's a lot of problems to be solved, and I think green infrastructure is something that's trying to solve multiple problems at once. You know, we need our money to do, you know, more for us in every project. And so that's what we're trying to do by incorporating green infrastructure into our normal roadway projects. So 2013 was our first bioswale. We have over 200 now. We're building another 75 this summer. I started in 2015 with the city, and I think they had about, I want to say, 10 bioswales at the time. So I've gotten to be a part of this like rapid growth, and it's been really exciting. And just having worked in other areas, you know, this workforce development, the outreach, the things that I'm describing, the process by which these are installed, I think has made it a really successful program. And so, you know, I was thinking to myself, kind of what are our keys to success? You know, necessity opened the door for us, mother of invention, right? So we, you know, it allowed the city to overcome whatever fears it had about implementing it, and we got started. I think we're very fortunate to have an open-minded city staff. The engineer that brought up the idea of a bioswale is now the city engineer. So he, you know, can make major decisions about how our capital is spent, and what types of projects we do. We also have a pretty nimble government structure, I would say. It's very easy for me, at least it was before COVID, to go downstairs and talk to someone from the traffic department and make sure that I'm locating this in a spot that's okay. Or to go talk to the public works director. You know, it's easy to access people in our city, and I think that makes it easier to get projects done. Adaptive management. It's frustrating at times to have a design and be like, okay, this is it, and then realize, oh, you know what, that fence keeps breaking all the time. We need a new type of fence. We can't, okay, we got to stop here. We got to go back. We got to change the design. And that's tough, but it's also made our design, you know, stronger. We're more comfortable with it. So I would recommend starting slow, you know, see what works, and then ramping up over time. That's worked for us. The partnerships, the co-benefits come from the partnerships that we have with our nonprofits, with our university. You know, we're getting research out of these. We're having workforce development. We're having, you know, greater acceptance. We're, you know, I think that all of these things are really important. And sure, we could be installing a bunch of bioswales, and that is also good because it's still green infrastructure, still providing air quality and health benefits and reducing temperatures. But, you know, I think green infrastructure makes, you know, what was normally invisible infrastructure more visible. And so it gets people talking about the problem of stormwater. And if you can use it as a tool for engagement, I think that's really a benefit and a huge way that we're going to be able to implement more and more. And then trying to find creative ways to fund these. You know, there is money out there, I've found, but, you know, we had to be kind of creative in the grants that we were going after and who we would work with. And you just kind of have to adapt to whatever the grant kind of needs from you. So that's all I have. I feel like I've been talking a lot. I can't wait to hear from you all. I hope I addressed something that you were hoping to hear, but I'm happy to answer questions about anything I said or anything you're thinking about that I didn't address. So thank you.
Thank you so much, Dawn. Do you mind unsharing your screen just so that we can all see each other?
Yep, absolutely.
And I have a very quick question just to get us going. You mentioned that that you were mostly going to talk about upland flooding or overland flooding, but then you were just going to touch on how that interacted with the coastal flooding, storm surge.
I'm sorry, yeah.
Can you touch on that?
Yeah, so yeah, if I had a map of New Haven, but so we have,
if you want to,
we have a large,
if you want to share it again too.
No, it's okay. So it interacts by, so we have our downtown area that's all paved, all that water is trying to get out. And then we have a rail yard, right? So we have this like depressed area, and then we have all this fill that's low lying. And so we only have 2 pipes going under the rail yard, trying to take all the water from downtown in these two pipes through this really low-lying area and out through two outfalls. And so when you have sea level rise, let's say, so now our high tides are even higher, and we have a storm event that hits on a high tide. I mean, it really depends on the intensity of the event, but if we have a bunch of rain falling at once, now the outfall's underwater, and we have a gate on it so that it doesn't back up, but that makes it really hard to push water out. And so, so now that our high tides are higher, and now we're having more intense rainfall more frequently, we're finding that we're getting upland flooding more frequently because the water can't push through that high tide without coming out above ground in our low-lying areas. So that's one way. And then that's even exacerbated more by a storm surge, because now it's even higher and the water has to rise even more to like push itself out of the outfalls. And so we find that we have the most problems during high tide, even if it's just a windy day and it raises the tide, it's so sensitive, like a half a foot, and we know it's going to rain hard. We actually have some monitors that just measure the depth, and they can tell us, in some of our problem areas when the water level's getting high, and they can send us alerts because it's just becoming, we haven't solved our problem yet and we need to respond. And so that's kind of how it's impacting.
Thank you.
And related.
So various people have got questions. Can I just know your time? Are you able to go on past the hour? I have a feeling that we have many questions.
Yeah, I thought you scheduled it till 2:30. I'm sorry I talked so long.
Okay, great. Great.
Yeah, I could say.
So Kathy had a question, and then David has raised his arm. And just a reminder to say your name, your group, your town, blah, blah, blah.
Yep.
Hi, I'm Kathy Sullivan. I'm from Elmhurst, Illinois. I will say that over my detention pond that my city has built, the Blue Angels flew yesterday, and it left a good picture. So if anyone sees my Facebook, K.A. Sullivan, great picture of the Blue Angels doing one of those flyovers. Aurora, Illinois, when we did a tour there of some bioswales, they did 100 rain gardens in 100 blocks, something like that. They used some traditional plants to gain some resident buy-in. So I just thought I'd mention that. That was one of the takeaways I took from that tour. I have two questions. One's a real quick one. Is a French drain the same as a bioswale? And is a fence necessary for these bioswales? I saw you had them on the ones that were within a block, but not on the ones on the corner.
Right. So good questions. I'm going to answer the fence one first because it's a little bit faster. The fence came out, so some cities don't use a fence, and we've moved to putting an elevated curb around that's about 4 to 6 inches high, around the ones in downtown at least, because we found that the fence was getting knocked around a lot. And I think it was kind of a subjective opinion by some of the people in the city that it was a liability issue to just have a curb because people may trip over it. So the fence is meant to be a visual to allow people to know. So it's a liability thing. Some people have said the fence isn't high enough to actually do anything liability-wise, and I do think this is somewhat subjective. We also did give residents on some of our first bioswales a choice between plant palettes, and I think that's a really good way to engage. So that was a good point. And then a French drain, I think of, do you mean, are you asking? I would say no, they're different, and partially because a French drain is a buried drain with rock that isn't intentional about, so the water's getting in from the pipe and underground, and isn't coming from overland, from a street or from the sidewalk, and isn't, I don't think a French drain cares what's planted above it. It could be just grass. It's really just about what's buried. Okay. It's like a dry well. I do think that's a form of green infrastructure, but some would argue that without the plants, it's not, there's kind of a...
Yeah. We do have a lot of people in the low spots in their yards because we're Illinois, it's a swamp. near Chicago. So we do have a lot of people who put in French drains, and I know if I try to explain bioswales, I would get asked that question because there's a lot of similarities in the way I would explain it as a lay person married to an engineer, though, at least. But yeah. So,
yeah, I think of French drains more like a downspout disconnect, a way to like kind of get water away from your house, from the hard surfaces. But
yeah, it tries to take your swampy spot and let it try to get through our clay, because we also have clay, so on top of swampy.
Yeah, so you kind of have to.
So it's try to get it down a little.
Dig deeper to get to, yeah.
Okay, thank you.
Wonderful. Thank
You're
you.
welcome.
Hi. Thank you so much, Dawn, for your presentation. My name is David Southgate. I'm here in Ponce, Puerto Rico, on the Caribbean coast of the island. I'm with a community, my neighborhood called Villa de Carmen, and also it's part of a broader neighborhood called Playa de Ponce, which is Ponce Beach, basically. We're participating, invited to participate in the National Fish and Wildlife Federation's Coastal Resiliency proposal. And I was curious about the bioswales. I'm not an engineer. I'm a project manager and a public administrator. And I'm wondering about unintended consequences of your bioswales. I'm hearing liability. I'm hearing garbage. We live in an area where mosquitoes are prevalent and also can bring disease. So I'm wondering if mosquitoes are an issue with these infrastructure.
We don't have mosquitoes. They don't stay filled with water for, I would say, up to a few hours after a storm, and then they're dry. That goes to having really sandy soil in them so that they infiltrate real fast. I'd imagine that Puerto Rico probably has pockets of areas that are pretty sandy with high infiltration, but it would be something you'd want to just kind of look into, your soils. But we don't have any problems with mosquitoes. Unintended consequences. As I try to cite these throughout the city, there's a lot of stuff in the right of way. There's already a lot of things in our sidewalk. People sue over tripping over, a tree root that has lifted the sidewalk and caused them to trip. I mean, liability, to me, it's frustrating to me a little bit because it just is what it is. We haven't had any issues with the 200. No one has sued us over a bioswale. Knock on wood. So I think we try to design our way, being intentional about the ways in which, make sure that we've done our due diligence to try to keep people out of them. We have a raised curb, we have a fence, we're screaming, here it is, please don't fall into it. Because the whole problem is you have to depress the soil lower than the curb. So, you have about 6 inches that, you could drop into. And so we try to be intentional about the liability. The only other unintended consequence that I would tell people to look out for would be, basement flooding. If you have really high groundwater and you're putting more water into the ground, just making sure you don't have like a localized effect. You can usually avoid that by staying at least 10 feet away from, that's kind of the rule of thumb, 10 feet away from a structure, but just something to look out for. Again, having very sandy soils, the water kind of goes down pretty fast, and we're not in an area where groundwater is pretty deep at this point for us. So we haven't had any issues there.
Thanks, Dawn. One other
You're
question
welcome.
related to the bioswale. There are a lot of areas in our neighborhoods that actually don't have sidewalks and don't have curbs. So I'm wondering if these bioswales can work in that sort of setting as well.
Yeah, I think, as long as you kind of have enough space to fit it, it's just, so actually one of the pictures I showed didn't have a fence, and that was because it was a rain garden on like a center mall type green space in between, a road, the traffic was separated by this big green space, and that didn't have a curb either. And so, it ran along kind of the grass or whatever, and then we just did a depressed garden. So that would be more like rain garden design, but yes, definitely could be done.
Thank you.
They're very adaptive.
Dara, Gordon, Susan, and then Suzanne.
Okay, hi, and thank you very much for your presentation. It was wonderful. I love the pictures. It makes it come alive. To get the guys that are in our county commission.
Sorry, can you just say who you are, where you're from?
Oh, I'm sorry. I'm Darlene Hartigan, and I'm the president of Save Our Soundside down in Santa Rosa County in the Florida Panhandle. We're at like zero elevation level, so we've got water that just sits, and then we now that they're building and with the fill and build development, they bring in the clay, so now we don't even have sandy soil, but
it's under there.
Yeah, and sorry about Sean the sheep going in the background. I'll ask my question and then mute. So we're going to have to really convince these guys to do anything green. And so I'm wondering if you have any data or formula that you can give to us, pass along, about how many cubic feet of water per cubic foot of soil in a bioswale we could estimate that how effective it would be. If you could speak on that for a moment, that would help. Thank you.
Yeah. So the problem is that we have this research being done, but there's a delay in getting it all processed and then written up. And but I do have some data from the research that was done that I could share. You have sandy soil, so maybe it will be comparable. I could also share stuff that I have. I'll reach out to Harriet from other cities as well. But we're finding that a bioswale can capture up to 70% of a rain event, up to a 1-inch rain event. So we're finding it to be really effective. But I can give you some data to support that for sure. You know, it's tough because it depends on how hard it's raining, and but we're finding kind of on average for an inch or less of rain, we're finding about 70%. And I can break that down into how much paved surface per vegetated. I don't have it off the top of my head, but I can get you that information.
Thank you.
Yeah, you're welcome. And just a clarifying question, are you asking your city to do this or developers? Just curious.
We are, after big outcry and groundswell movement, we are revising our land development code. So it will be ultimately part of development, but the county commissioners have to enact it. And so we were supposed to have already had all the public input, but with COVID, it's been postponed. It's bought us a little bit of time to do some research and things like that. So we're going to be hitting the county up in the next month.
So we have an ordinance in place that makes developers capture the first inch off of their site, and I'd be happy to share that with you as a model ordinance for
that'd be great.
for getting developers. So I didn't talk about that side of it, but I do. But we do have an ordinance in place to get developers to capture 1 inch when they develop over their site. Okay. So I could share that too.
Thank you.
Fantastic. Thank you. Gordon.
Take notes.
Now, you. Okay. Thank you for your presentation. It was very informational. I'm going to kind of like ask this question in a different way.
Don't forget to say who you are, where you're from.
I'm sorry. Yeah, okay, got you. I'm Gordon Jackson. I'm chair of the Environmental Climate Justice Committee for the Biloxi branch of the NAACP. And so I am calling with you from Biloxi. And of course, when you think about we're right off the coast, and our area, our South Mississippi area was really ravaged by Hurricane Katrina in 2005. And so still have some issues remaining, particularly in the community I focus on, East Biloxi, which is our people of color community. But you know, Gerard kind of stole my thunder with the type of questions she was asking. I'm just kind of asking it in a different way. That if and when you go before the city council and you try to sell them on just how effective the green infrastructure programs have been, I mean, what type of numbers have you been able to give them? You know, what percentage less flooding, or what percentage water that has been, flowed, things of that nature, and all, and so just how have you been able to sell the city on the benefits of green infrastructure?
That's a really good question. So we haven't had to sell it as hard, but we have done research. And so I don't want to misspeak, and I will definitely pull what I can from that research and make sure it gets circulated with this group. But we've had this 70% capture of storms that are an inch or less. So for each bioswale, depending what's draining to it, it can capture up to 70% of that storm. And we've done the monitoring where we build a bunch of bioswales and then we monitor in the sewer, and that's what we're finding. So it's showing that they've been very effective. But I can get some more research if that's. I would also try to sell them on, the multiple benefits, right? Because I'm sure there are, it's kind of like define the problem a little bit for them a little differently and say, well, we're going to have to spend money, and you're either going to spend it burying these pipes in the ground, or, we can create something beautiful in our communities. It's just another way to maybe approach trying to convince them. But, and if you get a grant, people are maybe it's a little easier to say, hey, we're going to use this grant to try it out to see how it works, as opposed to immediately using capital funds for the project. Maybe that would help too. That was kind of how we've started as well.
All right. Just a real quick second question. Most of your green infrastructure progress has involved bioswales. Have you looked into the other forms that has been discussed, like the rain gardens or green roofs, or any of the other different types? Have you tried those as well? Yeah.
So we've done a couple of rain gardens. We don't have as much space for those. We kind of have to work with what we own. That's what we haven't been working with private homeowners to do this outside of our development ordinance. And to be honest, most of the time developers are burying, perforated pipes and infiltrating the water, but then putting a parking lot over it. They're not necessarily doing green. And so we're hoping to revise our ordinance now to try to prioritize the vegetated solutions, but they are infiltrating the water and not putting it in our sewer system, but they're not creating maybe the green space that we were hoping they would. We haven't done a green roof. They tend to be more expensive per gallon captured, I think. So I think bioswales are a lower hanging fruit. Also, our streets cover about, at least in our downtown area, it's about 25% of our impervious surface. So that's a significant amount of water that we're trying to capture kind of first. And we did try permeable pavement, and I know there's lots of different types. We find that hard to maintain. You kind of need a special truck to vacuum it, and haven't found that to, also once it starts to decay, you have to repair it. We haven't found that to be as effective as well. So we've kind of found this to be, at least to be the most effective for what we're trying to do right now. But maybe as we kind of run out of locations for them, we'll have to kind of explore other options.
Thank you.
Thank you very much.
So we have Susan and Suzanne, and Susan Lyons, I see you have your hand up afterwards. It's Susan Liley first. Also, just so that Arthur, Queen Quet, and April and Camille know, your screen isn't on, so I can't see you. So if you do want to put your hand up, please either write something on chat or turn on your screen, or I think you can also put your hand up on Zoom. Wonderful. Susan, don't forget to say who you are and where you're from.
I'm Susan Wiley from Citizens for Flood Relief in DeSoto, Missouri. We're not a coastline. Everybody's on the coastline, it seems, but we have some big problems. I know that our city's first question when I bring this up is, who's going to take care of it? I know you said that if you bring people in, they will take ownership of it, but they want to know who's really going to take care of it.
Yeah.
And how much does a small one cost? Like the first one you showed, just a guesstimate.
Yeah. So the maintenance question is always a huge question. The way we see it, or at least I guess I'll speak in theory first and then what's kind of happened in practice. The way we see it is we already pay to vacuum out our catch basins. So all of the gutters that get all of the garbage, it's maybe hidden from public view until they're so filled that they start flooding. But, you know, we have to go and we spend, I don't know, $500,000 a year on sucking up garbage out of catch basins or sediments and other things. And so our idea was that we'll just, now that the bioswales will be capturing some of that, the pollutants from that runoff, we could take some of that money and use it to clean our bioswales. So that was always the way that we decided to do it. We also, with the same nonprofit, they got a grant to do maintenance for a year. And what they did with that is really document what it takes and come up with a maintenance plan for us, kind of. And so they came up with minimally, you should check on them 4 times a year, for us at least, given the way our seasons are, you know, after the winter thaw, you know, a couple other times. And then when leaf drop, you want to take all the leaves out before winter again. And so, you know, you could check on them more and that would be great, but they thought, you know, for regular maintenance, 4 times a year would be okay. And they kind of priced that for us. We put it out to bid and it actually came in more expensive. And so we're kind of going back to the drawing board, because the way we envisioned maintenance was, again, getting those co-benefits. So, you know, we got an article published in a local paper and people were coming to us and saying, hey, we'll do the maintenance as part of this workforce development program or part of our beautification program over here and whatever. So we actually had groups coming to us. And so I think we just need, it's procurement when you work for a city, you know, you got to do everything by low bid, or you got to do everything. So it's very honest, which sometimes is frustrating because you want to just pick the people you want to do it. And so we're kind of working through, well, how do we engage all these groups in a way that we can pay them for their services? We know it's going to be cost effective. And then COVID hit. And so we have some employees right now that are not able to do their normal work. And so we actually have a couple of them going around and cleaning. So they're being cleaned by the city right now, which may end up being the more cost-effective ways to get a seasonal type maintenance job or a full-time staff person that can spend part of their time cleaning these out. So I think there's different ways to do it, and we are, in all honesty, still working that out. The question of cost. So it will range based on who you work with to build them. So when the nonprofit was first doing these, they were just charging us for their time and materials, and they were coming out. Some of the couple that they built, they were like $2,000 or $3,000, which is relatively inexpensive for a 5-foot by 15-foot wide bioswale with fence. And now they're coming out in our downtown area, which has the most restrictions on having to, you know, hire cops. This is all the incidentals that go with constructing, you know, having cops that stand there and help protect traffic and all those things. Are coming out around $14,000. so they're not cheap. They are cheaper than other solutions. But you know, there's a range depending on how you build them. And if you don't need the fence itself is probably a good $1,200 with installation, you know, another $1,500. So there's things that if you can, we're also building them with a granite curb around them, you know, that's also expensive. You know, so there's elements that make it a little bit more expensive than the first ones. We just found in our downtown, we kind of needed the heavy duty. We were using this other fence that kept breaking. It was fine in our residential areas. It was not, I don't know what people are doing downtown, but it was not sort of holding up. So that's in the range. New York City, I think it's closer to like 20 to 25,000 for the same thing. So we feel like we've reduced it in our cost because I think because of the partnerships and because we've designed it to kind of take out some of the high skilled kind of expensive work, but they're still coming up, you know, maybe a little higher than we hoped.
Thank you. Just so you know, so people know, there are 4 people on this call right now who are part of what is the full proposal. So we got through the first stage and now we're going to the second stage of a bid to get their first pilot green infrastructure in place. So if we're successful, it'll be 6 communities in total for 4 people.
I'm also happy. That's really exciting. I'm happy to share design documents. You know, any of our designs I could pass around. You know, no need to. You know, we're happy to share those with anyone that needs them.
Thank you. If we're successful, then we might well be.
Yeah, reach out.
Suzanne.
Okay, hi, I'm Suzanne Hornick, and I am Ocean City, New Jersey flooding. We're a little barrier island, the southern coast of New Jersey. We also have sandy soil, so I want to see stuff. I just, 3 quick questions. The first one is, are you related to the famous Dawn Henning? She's a genius. Different area though. Okay, so the easy question is, how did you find the pervious concrete to work? You said you talked about the asphalt and you didn't like it, but I'm wondering about the concrete. My second question is, how did you measure the performance of the bioswales?
Okay, so I don't know much about our pervious. They were done before I was at the city, so I know we did relatively small installations. I think it was that they worked, but over time they were crumbling. And I couldn't, you know, was it pervious concrete versus pervious asphalt? It wasn't asphalt. I think it was more the concrete. And so we just haven't found it. We haven't found a good good reason to install it yet, I guess. We haven't found a good place that we think it would work better. I have developers that are coming in with pavers and other things that they're using on their sites that are pervious, but they're not monitoring them. So I'm not 100% sure how they're working over time. The University of New Hampshire has a stormwater center that they've looked at porous asphalt and concrete, impervious concrete, and they sing its praises. So, and they're in a snowy, you know, snow climate. So, and they say good things about it. So maybe looking to their site. Sorry, what was your second question? Oh, the performance. So,
how did you measure it?
So we've partnered with a professor at Yale University's School of Forestry, and he did it in 2 ways. He looks, well, there's a couple things. So he measures the water coming into the bioswale. Then he has a well that goes all the way down to the stone layer. And during a rain event, they'll measure how much water kind of ponds and how much water gets through in the soil layer. And then he measures before and after. So before installation, he's measuring what's going into the sewer as far as storm water. And then after the installation of bioswales, he'll measure what's going on and so you don't get exactly the same storm, but if you get enough storms, you can compare okay, so I was having this much rain in the sewer, and now I'm only getting this much water in the sewer. It's got to be the bioswales, because the only thing that changed. And so that's where he's getting the 70% number, where you know, he's finding a reduction in the sewer. That's kind of the short of how he did it.
Thank you. Susan Lyons. Don't forget to
Hi,
from.
I'm from Charleston, South Carolina, and I live in downtown, and they look beautiful. Thank you for your presentation. I wanted to ask, we have a very high water table here where we are, and I was wondering how that interfaces with digging down 5 feet or more in order to create the system that would work. Do you have to be pretty much above that water table? Is there a limit?
The rule of thumb has been 2 to 3 feet between the bottom of the system and groundwater. You may want to look at just kind of a traditional rain garden. And the way I should have defined this, the way I think of a rain garden versus a bioswale is that you don't dig all of that. You maybe do something in the first 6 inches to a foot to kind of make sure you have some good soil for the plants that's highly, you know, infiltrates really well. And then, but you're not doing all of that subsurface work. So that may be able to give you the benefits of capturing and infiltrating some water without having to get into the water table. But yeah, you'd want to keep some distance between.
So like 2 to 3 feet above
the
water table.
Above the water table.
Yeah. I know they have
maybe you could find some of your high-lying areas.
Yeah, because they have trouble with rain gardens here on the peninsula because there's no way to go deeper.
There's just no way to go deeper. Yeah, that is a challenge.
Yeah, it is. Thanks.
Maybe you should look at your rooftops then.
If they're not slanted.
Yeah, if they're not slanted.
Thank you.
Or actually, they've also built planters. You know, people have actually built planters to capture and like slowly filter water, and then eventually either you could store it after that or infiltrate it, but at least slows down the flow, which is, you know, it's not maybe taking it out of the system, but it's flattening that peak, which is important for flooding. So another option.
Thank you.
Flattening the curve. Any other questions? We've probably got time for one more. Yes, Gabriella. Don't forget to say where you're from.
I'm Gabriella Velarde Ward. I'm from Staten Island, New York City. And we're trying to prevent the destruction of a 30-acre wetland, 18 acres of which will be paved over with hard surfaces, 2,000 trees cut down, etc. We're in court right now fighting it. I've filed Freedom of Information Acts to get some of the plans. I got very limited amount of it, but it seems that the bioswales that the contractor's proposing or the developer's proposing has a pipe running through it, so it's not a bioswale. So I'm asking, because it's very permeable surface right now being a wetland, how much fill would they have to have there compacted in order to have the bioswale being effective? Because the water's at the surface during the season. It is.
I mean, in your case, obviously, no development would be the best.
Yes.
The underdrain issue, that pipe, we find even engineers that we work with always want to put in an underdrain, and we are always telling them to take it out because it goes back to engineers being uncomfortable with vegetated systems and, you know, not wanting to risk it. And so they want to have this safety valve essentially. And we're like, no, that's not the point of, you know, of green infrastructure. If you're going to have a safety valve, I would put it high up, you know, so at least you get infiltration until it's maybe right before it's going to flood, and then you can have a safety valve, but don't put it on the bottom. It would be, if you want to try to argue with them over where it should go. But I agree, the underdrain is frustrating. God, it's a tough one. If you're building on a wetland, how would these work? You know, I mean, you're in water. I'd have to kind of look at the specifics to.
They're putting a strip mall, a BJ's, a very large box stores, gas station, 2 other big buildings, parking lot for 835 cars. It's going to be huge. And so you're going to have to compact the soil in order to have a firm enough soil for the business. So I'm just wondering how deep that compaction has to be. And if a bioswale, before a bioswale can be effective.
Oh, I think they'll be effective. It sounds like they're going to have to bring in fill in order to do that project, you know, and I think you can definitely push them to, you know, even in parking lots, you know, I've seen like in between the spaces, just have a long green strip that's depressed and have all the water run off into that. I don't think you'd have to do a lot of necessarily, you know, as long as in the places that they're putting green infrastructure, they bring in good fill, because we know that times they just bring in maybe not the best material if they don't need to. So making sure it's clean and making sure it infiltrates. But I don't think you'd have to do all the stone and all the, you know, you could probably just have more of a rain garden type shallow depressed garden design that would capture the runoff.
It would have to be.
I think on a big BJ's, you should push it, and it's a new building. I would push for a green roof.
Yeah.
You know,
Bioswale
because
would have to be deeper than the compaction, though, right?
Because
Otherwise,
so one of the ways and actually New York City has a design where they put stone columns that would go through that compaction. So the water would run off and, you know, feed the vegetation. And then like I was talking about that gabion that goes into the stone layer, you could just have like a stone column that goes past the compaction into the soils that are better at infiltrating. So there's ways definitely to design overflow into the soils that aren't compacted. But if they're also building it, they could be more careful about compacting in the area where the green infrastructure is going versus where they have to put the parking lots and the building. We have developers all the time coming in, and they'll actually put stone on either side of these, you know, these chambers, these open bottom chambers. And then all the water runs off into this basically big stone and chamber pit, and then infiltrates into the ground after that. That's a lot of what happens with the ordinance that we have. But I don't know the background of the story or why they can fill in wetlands, but New Haven is pretty tough on keeping a 50-foot buffer away from wetlands. So I don't get a lot of, but we've already filled all our wetlands. So I mean, a lot of them. So we're guilty of it. It just happened earlier.
Thank you.
Thank you.
Yeah.
So we're at our time. I'm tremendously grateful to you. Thank you so much. That was so informative and so helpful. And I know everyone, and for us, actually, I realized there were 5 people on this call of the 6 who were all, with luck, if we're successful, will be able to build their own pilot project. So you've been a real inspiration to all of us. Thank you so much.
Yeah, if you have questions, feel free to email me. Feel free to share my contact info.
Thank you so much. Really, really appreciate it.
All right. Thank you very much. Thanks for having me.
Thank you.
It's great to meet you all.
Thank you.
Awesome.
Bye.
Good luck in all your work.
Bye.
Bye.
Bye.